Geotrig, lesson 39, day 1. We're going to talk about radian measure of angles. Up till today, we've only dealt with degrees. Degrees are contrived. It's something that we sat down and said, hey, there's going to be 360 degrees in a full entire circle. So now, when I say 30 degrees, you know where 30 degrees, which is 30 out of 360. But in the real world, there's a naturally occurring number. There's a naturally occurring thing called radians. And 1 radian, guys, is the central angle formed when the length equal to the radius of the circle is measured on the circle itself. So, if you look at the left circle, 1 radian, which is the central angle, which is the angle at the center. So 1 radian happens to be 57.29 or 57.3 degrees, give or take. But if we talk about a radius of any circle, and we take the radius, which is here, and I was to bend it around the circle starting at 0, that distance that's covered would always be the same. It's actually kind of cool. And so, that's 1 radian. Or, if you take the distance of a circle, distance around a circle, and divide it by its radius, you end up with 2 pi. 2 pi is the distance around a circle. There are 2 pi radians in a circle, which is, if you remember what pi is 3.14. Da-da-da-da. So 2 pi is 6.28. So therefore, on a full circle, you have 1, 2, 3, 4, 5, 6 full radians, and a little bit of leftover, which is about 0.3 or 0.28. All the way around a circle is 6.28 or 6.3 radians. Okay? So, remember that the central angle is the same as the distance on the circle as in degree-wise. So, we can have a 30-degree arc, which means our central angle is 30 degrees. But now we can talk about a central angle being pi over 6. That means the distance at curvature on the circle is also pi over 6. Okay, that's what I'm trying to say here on this. We are going to have to know what the radian measures are of the unit circle. Or, really, what's the radian measure of any angle? And know how to go from radians to degrees to radians. The next slide is going to help us transfer back and forth, convert. Okay. There it is. A full circle is 2 pi, which is 360 degrees. So therefore, 2 pi is equal to 360. Or, if I divide both sides by 2, what is equal to 180? Pi. That seems to be pretty natural. Easy, no? Now, if you guys agree, or maybe you guys would agree, that 12 inches is equal to 1 foot. Or 1 foot is equal to 12 inches. So if you started with, let's just think of this, if I start with 1 foot, how can I convert that to inches? Multiply it by 12 inches per 1 foot. You do this because what happens? The feet or foot cancels, right? So it's 1 times 12. The same thing is going to happen. Guys, that's called what? Dimensional analysis? Trying to cancel out your units. The same thing is going to happen when you convert degrees to radians or radians to degrees. What you need to start to be careful about is that if the book doesn't put a degree sign on a problem, you almost have to default to radians. Because there is such a thing as 30 radians. 30 radians is a multiple of 6.28, right? Multiple times. That's just going around the circle a couple times. This is kind of like saying 1080, right? 1080 degrees. It's more than one time around the circle. So today, we are going to need to convert 30 degrees, 45 degrees, 120 degrees, 516 degrees to radians. Something on those lines. But then we're on the flip side going to get rid of pi with pi over 3, 11 pi over 6, negative 3 pi over 4, and convert those to degrees. And it's all done using dimensional analysis, canceling your units. So if I want to go from degrees to radians, we use, I don't know why I put the line in there. I multiply the degrees by pi over 180. Because pi is equal to 180, that's our multiplier. And the whole idea is that degrees that are on top will cancel with the degrees on the bottom, leaving you technically, and they don't write it all the time, pi radians over 180 degrees. Or 180 degrees over pi radians. If I want to cancel the radians, or pi's, I put pi on the bottom, put degrees, 180 degrees on top. It's as easy as that. So 30 degrees. I'm going to multiply that by 180 on the bottom, pi on top, which is pi radians. The degree symbol will cancel, so they're gone, and you're left with 30 pi over 180. Now, when you're working with radians, you're going to leave pi in there. You're going to just reduce the fraction. You are not going to go to some crazy decimal. Leave it in terms of pi. It'll make your life easier in the long run. Reduce it. What's 30 divided by 180? Yes, it's 1/6, so it ends up being pi over 6. And if you want, you can put radians on there. You don't necessarily have to, because it's implied. Okay? Radians is one of those weird units that are actually are able to be added or deleted kind of at will. So, looking at 45 degrees, I'm going to multiply that by what? Pi over 180 degrees. So you end up with 45 pi over 180. And then by 9, okay. So that'd be 5 pi over 20. I can reduce that again. That becomes pi over 4. Wait a minute. Isn't 30 on our unit circle? Doesn't 30 make up a lot of our angles on the unit circle? Doesn't 45 end up on our unit circle? A lot of the others are made up of 45 degrees, like 45, and then 90, and then 135, and then 180, 225, 270, 315, 360, 300, 350. 120. Do the same thing. I'm going to multiply this one by pi over 180. To get 120 pi over 180, we can definitely cancel out the zeros. I could do that for almost all of those there. And then 12 divided by 18.
6.
So 2 pi over 3. Here's an interesting thought. How many 30s does it take to get to 120?
4. It takes
4 of them. So if I did 4 times pi over 6, hey guys, 4 times pi over 6, it would be 4 times like 30 degrees, right?
Yes, it would be 4 pi over 24.
It which would be 4 pi over 6, which is again 2 pi over 3. So there's a couple different ways. Now there's one angle that we didn't talk about here, which was probably one of our main ones, is 30, 45, and then 60. The 60 is probably a big one, and so is 90 degrees. But you guys will do those in your homework and through all our things. Then on the bottom, are there any questions on converting to degrees? Or sorry, radians. Not that big of a deal. Then on the flip side, I got radians already, pi over 3. I need to convert that to degrees. So, multiply by the other multiplier. I want the pi's or radians to cancel. So I multiply 180 degrees by pi. They cancel. What's 180 divided by 3? 60 degrees. So guess what? 60 degrees is pi over 3. You should know that. These are the 3 main ones are the first 3 here, the first two red ones, and the one in the black on the bottom. 30 degrees is pi over 6. 45 degrees is pi over 4. 60 degrees is pi over 3. Those 3, if you know those, you can build any other angle on the unit circle. Okay? Very important. 11 pi over 6. Multiply it by?
180 over pi.
Over pi. What happens to the pi's? Cancel. Now, you could do 11 times 180, right?
You can divide by 6.
Or divide, and then divide by 6. Or would it be easier to take 180, divide by 6 to get what? 30?
30.
And 30 times 11 is?
330.
330 degrees. Now wait.
Whoa, what?
11 pi over 6? Isn't that the same thing as 11 times pi over 6? And what was pi over 6 again? 30. So it's 11 times 30. 330 degrees. A couple different ways to convert here, guys. Okay? Now here's the thing. Degrees and radians can both be positive, can be negative. All it means is that when you're starting on the positive x-axis, do I go up or do I go down? Right? That's it. So the next one's a negative 3/4 pi. No different than what I did before. Multiply it by pi over 180, or 180 over pi, sorry. So the pi's cancel. And then you could do negative 3 times 180 divided by 4. Or take 180 divided by 4 and multiply it by 3, or negative 3, which is a negative 135.
What's 180 divided by 4?
45.
45 times negative 3 is negative 135. Gotcha.
Any questions? That's degrees, sorry, I should put degrees. Now, I said generally, radians have pi in it, but they don't always have to be. There is, guys, the option to go 4. If you say, hey, I just went 4, it does not mean 4 degrees, it actually means 4 radians, because there's no degree symbol. It defaults to radians. If I want to convert from 4 radians to degrees, you will have to multiply by 180 over pi. Yes? That's 180 degrees. Well, the radians from the pi and the 4 will cancel each other out. Radians is out. We are now degrees. But because there's still a pi in here, pi is going to stay. And this is where it gets confusing. Because now it's 4 times 180 divided by pi. 4 times 180 is 720. So the actual answer is 720 over pi degrees. Now, if I was really going to use this angle, because it's in degrees, I would actually convert that to some kind of decimal. Take 720 on the calculator, divide it by pi, not 3.14, but the pi button. You will end up divided by about 3.14, so you know the answer itself is going to be just about over 200 something, right?
Okay.
About 240 or 230, 220, 240? Somewhere around there. Okay? It does exist. There exist radians that are 4, 5, 6 radians that when you convert it, it's going to be some not so nice decimal when you get to degrees. So what we need to do with this is just like we had to do before. We had to find coterminal angles. What's a coterminal angle, guys? You've done this before. I think we did it yesterday. Or the day before. The day before yesterday. We did coterminal. Someone give me a definition of a coterminal angle.
That was like the 360 plus, or it was like negative 475 degrees, and then you add 360 to get something.
Right. We added or subtracted 360 or multiples of 360 because if your eyes were closed and you turned 360 degrees and opened them again, you would see the exact same thing, right? Because you're in the exact same position. Well, I guess this time, guys, I'm not in degrees, I'm in radians. One full revolution in radians is what? How far is it all around the circle? No, in radians.
6.3.
6.3, but now I don't want to use decimals. It is
6.2.
2 pi. So I'm not going to add 360 or subtract 360 or multiples. I'm going to add or subtract multiples of 2 pi. Here's the thing. First problem is 2 pi over 3. If I add 2 pi, do I have an issue? What's the issue? Right. I got a fraction and a non-fraction. The only way I can add those is to have a common denominator.
3.
The common denominator happens to be a 3. To make that a common denominator, I need to have 3 on the bottom, but if I multiply the bottom by 3, I have to multiply the top by 3. So this becomes 2 pi over 3 plus
6 pi.
6 pi over 3, which would result in 8 pi over 3. Is this a positive or negative coterminal angle? Positive. That means I still need to find a negative. So, go back to the original problem and subtract 2 pi. Guess what I'm not going to write?
Negative?
No. I'm not going to write 2 pi. I'm going to write I've already found what 2 pi is as a common denominator. Why wouldn't I use that to my advantage? Why do more work than I have to? I already know that 2 pi over 3, to have a common denominator with 3, is 6 pi over 3. So that way now, when I subtract, I end up with negative 4 pi over 3. Positive and negative coterminal angle. I'm going to pause the video, and I want you guys to do 7 pi over 6 and negative 23 pi over 6. 7 pi over 6. I'm going to add 2 pi, which actually needs to have a common denominator of. So it's 6 over 6. So 7 pi over 6 plus 12 pi over 6, which results in an answer of 19 pi over 6. Then, I could take 7 pi over 6 and subtract.
I did 2.
Wait, why do you have to use 2?
Because that's the whole pi.
2 pi represents a full revolution around the circle.
Because I put a 7 2 and I was like, I got 49.
Yeah, don't do that. 7 pi minus 12 pi? Negative 5 pi over 6. Guys, what we are showing here, listen to this, guys, is the fact that if we go back to the original problem of 2/3 pi, 2/3 pi is actually the same, essentially, as 8 pi over 3 or negative 4 pi over 3. You can get there moving those angles, right? That's what it means to be coterminal. If I start at 0 and go 2/3 pi, I end up in one spot. If I go positive 8 pi over 3, I run past it, and then turn right back to it, I'm there. Or if I go a negative 4 pi over 3, I turn backwards, and I end up in that exact same spot. Same thing works for 7 pi over 6, 19 pi over 6, and negative 5 pi over 6. This is awesome. So, again, I want to find a positive and negative coterminal angle to negative 23 pi over 6. Wait a minute, didn't we just do that one to save us time? I'm going to add what? 12 pi over 6. Now, when I add 12 pi over 6, it's going to result in what kind of number? A negative. So that tells me I have actually just found a negative 11 pi over 6. Is that a positive coterminal or a negative coterminal? It's a negative coterminal angle. If I recognize that, am I going to now subtract 2 pi or the 12 pi over 6? Now just find another negative. I'm not going to do that unless it's advantageous for me to do that. And in this case, I want to find a positive. So I'm going to take the negative 11 pi over 6 and do what? Add another 12 pi over 6. So that, not this one. That's one answer plus 12 pi over 6, which results in pi over 6. And therefore we have the 2 there. Okay? We do this, guys, for this reason. Just like before, we did the sums and differences of trig identities, or trig functions, with angles that were larger or smaller than 360. Now we are going to do or evaluate trig functions with values that are smaller and larger than 0 to 2 pi, or just in radians in general. So we may have to find, and actually I'm looking at this, we might have, we will at least once, find coterminal angles to make this work for us. Okay? But we're also going to have to do some things here that we may have to modify our unit circles to add those radians to. Because I'm looking at this problem of 4 times sine of pi over 4 plus sine of a negative pi over 3. What's pi over 4 again? Where is pi over 4? How many degrees? It's 45. Hey, wait a minute. So at 45 degrees on your unit circle, what's the sine value? Square root of 2 over 2. So that means this is 4 times the square root of 2 over 2. Plus, I need to know the sine of negative pi over 3. That is 60 degrees, but if that's a negative 60 degrees, which means if I go downwards or backwards 60 degrees, where am I at? 300. What's the sine at 300? What's the sine value at 300? It's a negative square root of 3 over 2. Are we seeing those guys? I took it one step at a time. In this case, we switched everything to degrees because that's all we know. So what we should do as part of your homework is to go through your unit circle and fill in all of your radian measures, those extra lines on your unit circle with the appropriate radian measure, reduced radian measure. Because now, here's the thing, I got to put those together. To put those together, I should have a common denominator. Do I have it now?
Yeah.
But if I want to simplify that very first fraction, what would happen with the 2's? Or the 2 and the 4? They would cancel, then creating not common denominators. So therefore, I propose that you put the 4 to the top, leaving it over 2, so that you can put this together. What should be 4 square root of 2 minus square root of 3 all over 2. There is the exact answer to 4 sine pi over 4 plus sine of negative pi over 3. Okay? Next problem. 13 pi over 4, guys. I don't like it. 13 pi over 4 is a couple of times around the circle, or at least more than once. What's the coterminal angle to 13 pi over 4? That's within 0 to 2 pi. Isn't that 13 pi over 4 minus 2 pi? Which is, I have to multiply by 4 over 4. Or 13 pi over 4 minus 8 pi over 4.
So that would be 5 pi over 4.
5 pi over 4. So this is the sine of 5 pi over 4. Negative 5 pi over 3. I don't like negative angles. Add 2 pi to that. Negative 5 pi over 3 plus... Wait a minute. Is that okay? I did that right away? All I did was multiply top and bottom by 2 pi. Or 3, right? So that's why 3 times 2 pi is 6 pi. Which actually ends up being pi over 3. What's pi over 3? Or what's pi over 4s again? 45. If I have 5 45s, I have a good start of a record. Oh, anyways, but you guys might be too young for that one. What's 5 times 45? 225? Go to 225. Or 5 pi over 4 when you eventually, tomorrow, what do you get? Negative square root of 2 over 2 plus 3 times, what's the cosine of pi over 3? Pi over 3 is 60. What's the cosine of 60? 1/2. So negative square root of 2 over 2 plus 3 over 2. Boom. Your homework tonight. Fill in the unit circle for radians. It's going to be checked. Have a great day.